Okay, so I'm going to go over these 8 problems, send out a video to you guys, give you a little more help at home. Hopefully this will help you out. You all saw these problems in class, but I'm just going to give you one more shot to take a look at it if you still had any questions on how to solve some of these or any misconceptions. So here I got this problem right here. What I'm looking at is right over here I got a rational, a complex fraction, and then I'm adding another rational expression to it. Now when you're solving a problem like this, what you want to do is you want to focus right on this complex fraction right here. You want to simplify this down as much as possible. Once we simplify this down, what we're going to do is we're going to add whatever we get there to this 4 over x plus 5. So I'm going to start by simplifying this complex fraction. Now remember, when you're simplifying a complex fraction, what you do is you take the top fraction right here, the 4x plus 20 divided by 5x, and what we're going to do is now we're going to multiply that by the bottom, but you don't multiply the bottom as is, you've got to multiply it by the reciprocal. So we're going to take this negative 10x squared that's on the bottom and put it in the numerator, and then take the x squared minus 25 and put that in the denominator. So you're going to get something like this, 10x squared on top, and we're going to get x squared minus 25. Okay, so that's what that purple thing turned into right there. And now we're doing multiplication. Now if we go back to multiplication, the key thing to do is look at each section separately. So we got this section, we got this section, we got this section, and then we got this section right here. Look at each of them separately, and what we're going to do is we're going to try to factor each of these. So let's start on this top left blue section right here. What can we take out of this 4x and this 20? Is there anything common that we can factor that? We know we can't do the little x thing because there's no square. So if I look at both of these are divisible by 4. So I can take a 4 out. And what's left here in this first part? Well, it's just an x now because 4x divided by 4 is x. And what's left here? We just have a 5 because 20 divided by 4 is 5. So that's that one all factored. Then we look at this 5x, and 5x really you can't factor that anymore. So that one's as good as it can get. And the same goes for this top 10x squared. Can't factor that at all either. So 10x squared is as good as it gets. Now this red area, this x squared minus 25 right there, you can actually factor that a little bit more. This actually turns into being an x plus 5, x minus 5. Okay, now we look at this and we ask ourselves, how can we simplify this a little bit more? How can we simplify this area right here? Well, what you want to try to do is, because everything's being multiplied, you can just have one fraction bar, and you can cancel common things on top and bottom, common factors on top and bottom, because everything's being multiplied. So let's take a look. We have this x plus 5. We can cancel off with that x plus 5. And a 5x here. See this 5x right here? And this 10x squared? Well, if we focus on the 5 and the 10, that cancels off that and leaves a 2 on top. Okay? And the green x right down here cancels off one of these x's here and just leaves an x on top. And that's all you can do to simplify this. What we have at the end is we have this 4 and this 2x right here. That gets us 8x on top. And on the bottom, we just have this x minus 5 right there. So that's our bottom, x minus 5. Okay, now we got our solution to that purple area. This is our solution to this right here. So what we're going to do is we're going to rewrite this whole thing again. It's going to be, we're going to take this, bring it up here. That's a nice looking arrow, isn't it? So we have 8x over x minus 5. That's from what I have right here. And then we are adding this 4 plus x, or 4 over x plus 5. There we go. Okay, now we're just adding these two fractions. Sadly, we do not have a common denominator. Remember, to get a common denominator, you have to only multiply. You can't add or subtract. So what's missing over here? That's over here. Well, this one has an x plus 5, so we got to bring that over here, x plus 5. Got to do it on top and bottom. You're always multiplying. This one is missing the x minus 5, so let's bring this x minus 5 over there. X minus 5, x minus 5. On top and bottom. Now we got that common denominator we were looking for. It's x plus 5, x minus 5. Now, we're going to focus on simplifying this top right here. Let's focus on this area first, right there. We're going to figure out what this is when we distribute this 8x to the x and to the 5. So we have 8x times x, which is 8x squared, and 8x times 5, which is plus 4dx. Okay, so that's that area. Now let's focus on this. Now remember, we're adding. So we're going to add this. I like to put parentheses here just to keep track of all the things. Remember, we're going to be adding this whole thing, so if there's like a double negative there, we want to keep track of that. We're going to do the 4 times 5, which gets us 4x in here, and 4 times negative 5, which gets us negative 20. Okay. Now at this point, this is a common mistake people make. They start wanting to factor maybe the top right away now. At this point, you want to combine all like terms. Okay. You want to combine the like terms on the top and then see if we can factor. Excuse me, everyone. So to do that, let's look at all my x squared terms. Here's an x squared term. There's no other x squared terms. So I got an 8x squared on top. Then I'm going to look at all my x terms. Here's an x term. There's another x term. So I have 40 plus 4x. 40 plus 4x is 44x. And then finally, my constant terms. I only have one constant term. I'm adding, see I'm adding up negative 20, so that means minus 20 right there. And this is all over x plus 5, x minus 5. Okay. So now I want to see if I can simplify this a little more. Now we're going to try to see if we can factor this. Sometimes you can't factor it, and this actually turns out to be a situation. But I'm going to show you the process that you would take to try to factor it to figure that out. The first thing, we're going to try to factor this top. What do we notice in common in each of these things? Well, you could pull a 4 out. You could pull a 4 out of the top. Okay? And if you did that, what's left with this 8x squared? Well, we have a 2x squared there. What's left with the 44x? We have 11x. And what's left with this negative 20? Well, negative 20 divided by 4. Did I do this right? Negative 20 divided by 4 would be negative 5. Okay? So we factor that 4 out. Now we want to try to factor this section right here. And to do that, we're going to use the sliding method. And remember how the sliding method works. We take this 2, we multiply it by this 5 right here through multiplication. And then we're going to take that 2 times 5. We're going to make our x over here. So we get a negative 10, because that's what 2 times negative 5 is. That's negative 10. And then we're going to take this 11 and put it on top. So we're going to ask ourselves, what times what is negative 10 that adds together to be 11? So you start with, what? Do you want to change your color? Why you ask me that? Okay, back on it. I'm back on track. We got 10 and then 1. That could be multiplied to be negative 10 if you make one positive or the other one negative and one positive, but nothing seems to do it. We could also do 2 and 5, but that doesn't get us to 11 either. So it looks like this is not factorable. And because it's not factorable, your final solution would be this. Now, you ask if you take this numerator and you factored it to be that and you put that in, of course I'll take that too. I'll take that too. I might have to give you that solution later. I might give you credit for it later, but I'll look for it and I'll give you that credit. So that's how you do this problem. This is probably one of the hardest problems you're going to see on this upcoming test, right there. A lot to it, but doable. And what you need to do is you got to take your time on this. If you don't take your time, you're going to make mistakes. And we know what happens when you make mistakes. We just got to find them. That's what I have to do. So take your time. Okay, moving on, next one. Excuse me again. So here, I got 2x plus 3 over 9 minus 3x minus 5 over 6. I'm going to look at this. What I'm going to do is I want to get a common denominator before I can add these. I can't, or subtract them. I can't do it without that. I notice that 9 is really 3 times 3. And I notice that 6 is 3 times 2. Okay? So noticing these two things, I ask myself, what is over here that's not over here? Well, I notice this one has 2 3's, so I need another 3 over here, so I'm going to multiply by 3 on top and bottom. And then, now what's over here that's not over on this side? Well, I notice this one has a 2, so I multiply 2 on top and bottom. And now I got a common number. Got a common denominator right there. Notice my common denominator is 2 times 3 times 3, which is the same as 3 times 2 times 3. That just turns out to be 18. Now let's focus on our top right here. We're going to bring this in. I got my 2 times 2x, which is 4x. And I got my 2 times 3, which is 6. I'm going to subtract, because of the subtraction sign right there. Subtract, put parentheses around it. Now I got my 3 times 3x, which is 9x. And I got my 3 times my negative 5, which is negative 15. Okay, got to combine like terms on the top. So, 4x right here, 9x. I got 4x 4x minus 9x. 4x minus 9x. That gets me negative 5x. Okay. This is the tricky one. This is one where I'm going to see a lot of people make mistakes. I got 6 minus negative 15. You forget about, a lot of students forget about this subtraction sign there. 6 minus negative 15 is the same as 6 plus 15. 6 plus 15 is positive 21. And that is all over 18. Now you want to look to see if you can factor anything out of the top here. Can you factor anything out of this term and this term? No, there's nothing you can factor out. So there's nothing to cancel on top and bottom. And so you just square it off. That's a horrible square. Isn't it? Horrible. But it doesn't matter. Moving on to the next one. Okay. Again, we're adding, subtracting. We need to simplify this problem down. First step is to get a common denominator. I noticed right off the bat that this x squared minus 9 is x plus 3, x minus 3. And I'm seeing an x plus 3 here, which is great because that's right there as well. And so I need an x minus 3 here. But notice that this is 3 minus x, not x minus 3, which is a shame because 3 minus x is not equal to x minus 3, just like 4 minus 2 is not equal to 2 minus 4. So we need to make this 3 minus x into an x minus 3. And here's how you do that. What we're going to do is we're going to multiply this by negative 1. But that's not legal, right? You can't do that. You're changing things if you do that. Well, you're actually not if you make sure you multiply both the top and bottom by negative 1. Because if you multiply the top and bottom by negative 1, this whole thing right here cancels off. So you really didn't change this last fraction right here. You just made it look a little bit different. So if I were to write this last fraction right here, I would get negative 1 times 2, which is negative 2, all over. Negative 1 times negative x, which would be positive x, and negative 1 times 3, which would be minus 3, right there. And then we have our plus. We'll bring that down. I'm going to rewrite. We got 4 over x plus 3. And then I have right here, oh, yeah, that's not what I want to do. There we go. Then I have 5x, that's from this, over x plus 3, x minus 3. Okay, now we're all set and ready to go. So, oh, don't forget the subtraction sign right there. Bring that down. So now we got to get a common denominator. Looks like we're all set to do that. This x plus 3 is missing the x minus 3 in the denominator, and this x minus 3 is missing the x plus 3. Right there. Okay. So we got a common denominator. That means we can write this with one nice big fraction bar. I have an x plus 3, x minus 3 on the bottom. And then we're going to focus on each part separately. First we'll focus on this 5x. That one's nice and easy. Then we're subtracting. Now we'll focus on this 4x minus 3. So 4 times x is minus 4x. 4 times negative 3 is negative 12. Right there. Okay. So we have that at that point. Now we're adding this to this right here. Negative 2 times x plus 3. Well, negative 2 times x is negative 2x, and negative 2 times 3 is minus 6. Okay. So we're at this point right now. We got our numerator, but we got to start combining the like terms. So let's first start with how about the x's? Let's bring this 5x together with this 4x along with that negative 2x. So here's how we read this. Don't lose these subtraction signs right here. We have 5x minus 4x, which is 1x, right? 5x minus 4x, which is 1x, plus negative 2x. Well, 1x plus negative 2x is like 1x minus 2x, so we get negative x for our x's. Okay. Now let's try this other one. We got, here, check this out. This one's tricky. We got negative 12, right? Negative, see this negative here? Negative 12. So negative and negative 12 is positive 12. So we got positive 12 plus negative 6 right here. That's negative 6. Negative 12, or positive 12 plus negative 6 is actually a positive 6 right there. So we bring those together and we get that. And then on the bottom we bring our x plus 3, x minus 3. Right there on the bottom. Now we ask ourselves, can we factor anything out of the top or on the bottom or cancel anything off? Well, sadly nothing cancels, so we box this off. This is the end solution. Okay, moving on to the next one. Whew. Oh, thank God, look at this one. This one has a common denominator, making this one a little bit easier to do. We can just start off saying, hey, we got x plus 8 in our denominator. And then what we have to do is we're going to focus on this 5x minus 1. Can't really simplify that at all, so this is 5x minus 1. And then we're going to subtract, in parentheses, 3x plus 4. We just got to bring together like terms at this point, just like in the last problem. So we have 5x minus 3x. 5x minus 3x, the positive 3x, is a 2x. And then our other one is, we got negative 1 minus 4. Negative 1 minus 4 is like negative, yeah, and that's just negative 5, right? That's negative 5. And that's all over x plus 8. So we get 2x minus 5 over x plus 8. We look at the top. This is us looking at the top. Can we factor the top at all? Nope, we cannot factor the top at all. So there's nothing, and we can't cancel it with the bottom at all. And so we just square it off. That's your final solution. Oh, this is going well. Okay. Moving on to this one. Okay. So I'm going to teach you, like I taught my 6th hour, a new way to solve these type of problems. This is how it works. What we're going to do is we're going to take this and we're going to put it into Desmos. And we're going to let Desmos do the work for us to solve this. And what we're going to be looking for is where does this equation, where will it cross over the x-axis? Well, before we do that, we got to get everything on one side of the equal sign and have it be set equal to 0. So this is what I want you to think of. Let's just imagine this whole thing right here is A. And this whole thing right here is B. And this whole thing right here is C. Okay? So if we had A plus B equals C and we wanted to get this whole thing equal to 0, I'd subtract C from both sides, right? If I subtracted C from both sides, I would have A plus B minus C equals 0. Okay? So notice how I just kind of shifted the C to the other side and became a subtraction sign in front of the C right there. We're going to do the same idea here. It just looks a little more complex because we have all these fraction bars. Okay? So I'm going to take this 2 over x squared minus 6x plus 8. I'm going to subtract this side by 2 over x squared minus 6x plus 8. And I've got to do it, remember, I've got to do it to both sides. So I'm going to subtract this side by 2 over x squared minus 6x plus 8. Okay? Now when I do that, what do I have left on the right side? Well, this and this cancel out, and we just have 0 on this side. And on the left side, what I have is x over x minus 2 plus 1 over x minus 4 minus 2 over x squared minus 6x plus 8. Right there. Now I want to show you a trick. Check this trick out. This makes life maybe a little bit easier because there was a lot of work just to kind of get to that point. We don't have to make it so hard. You don't have to make it that hard. Check this out. If you have one fraction on the right side of the equation line, and you're just going to try to get it over to the left side and set it equal, notice the only difference is you just got to make this a subtraction sign like there, and then you have to set it equal to 0, and then you got it. So just make this equal sign a subtraction, and then set it equal to 0, and you've got that. Okay. Now once you get everything over on this side, what you're going to do is you're going to take this right here, and you are going to type that into Desmos. So I'm going to do that on Desmos right now. Let's get that up, launched up. Okay, so I'm going to start with my x. I'm going to divide x minus 2. What's nice about Desmos is it makes it look like the problem, right? That's kind of the positive of it. Where if you put this in your graphing calculator, you would have to put parentheses around this bottom right there. And if you did that, or if you didn't do that, you would get it wrong. But in Desmos, no, not so much. Here we also got 1 divided by x minus 4. And then we're subtracting the whole right side of the equation. 2 divided by x squared minus 6x plus 8. And the key thing to do is, once you get it in there, you want to turn it on. See how I toggle the graph on and off? You want to make sure you just put it in right. So you just look at your paper and just make sure, did I make any mistakes? Type it in. Like first period I made it x over x plus 2 instead of minus 2. Just checking it over. 2x squared minus, oh, looks good to me. Okay, so now that we have this graph right here, here's what you're looking for. You're trying to figure out, where does this function right here, where does this function cross over the x-axis. Where does it cross over the x-axis? This is your x-axis right here, the one I'm doing in green. That's how you're trying to figure out. So we can actually see where it happens. It happens right here, right? That's where we're looking. What's nice about Desmos that isn't on your graphing calculator, well, it's not as easy. It is there. Is Desmos gives you key features. You just gotta click on the graph once. See how I clicked on the graph, and then it'll give you key features of the graph. It'll put little dots on them. So notice right here, I hover over that point. And it says, oh, it's crossing over the x-axis at -1. It actually tells you about where it crossed over the y-axis too. So key features. You want to check off to the left and right. It doesn't look like it's crossing over the left. It doesn't look like it's crossing over to the right. I guess that, I'm sorry, I did those in the opposite way. So our solution is -1. That's our solution from just looking at this. X equals -1, and you're going to put that in to your graphing as -1. This is how you put it into Moodle right there. But we can't be sure it's -1. We got to take this -1, and still we got to check to make sure it does not make a 0 in any of these denominators right here, here, here. So what I mean by that is if I take -1, I plug it in for this x there, if I plug it in for that x there, if I plug it in for these x's here, none of these denominators equal 0, because remember, when you divide by 0, bad things happen. You can't do that. So let's look at this first one, this x minus 2. If you have -1 minus 2, does that equal to 0? No, it does not. Okay, so that one's good to go. Let's look at this one. If you had -1 minus 4, does that equal to 0? -1 minus 4 is -5, so no, it does not. And we got this last one. We have -1 squared minus 6 times -1 plus 8. That's 1 minus plus 6 plus 8. Is that equal to 0? No, it does not. It does not equal to 0. So we're good. We never divided by 0, and therefore our solution here is equal to -1. There you go. That's how you do that problem right there. Now, I'm going to skip this one right here. We'll come back to this one. Again, I do not want to change it. Gosh. And then we're going to do this one right here. Okay? We're going to do this one the same exact way. Remember, the first thing we want to do is we want to get this right here equal to 0. So we're going to take this right here, and we're going to move it to this side by subtracting it. Okay? And when I do that, I got my 2 over x minus x over 5x plus 12 equals 0. And that's what I'm going to put this part right here into Desmos and graph it. Okay? Now, just so you all know, if there was a negative in front of this right there, if there was a negative, then it would be plus. You would add it to both sides. But there isn't. There isn't. So let's go back to Desmos. You can keep your old function there. You can shut it off. See how I shut it off right there? And we're going to type this new one right here. So I got my 2 divided by x minus x divided by 5x plus 12. 5x plus 12. Okay, turn it on so everyone can see it, and we're going to figure out where it crosses over the x-axis. It looks like it crosses over 2 points. You see that? Let's zoom in on this one a little bit. Looks like it crosses over at -2. That's a possible solution. We're not sure yet. -2 is possibly one. And it looks like it crosses over again. Look at, and remember, it's tough to tell, but remember, if you click on the graph, it puts the little dots, and the dots tell you exactly key points. So it looks like -2 and 12 are possible solutions to this. So let's take a look at those. Let's write those down here. I'm going to clear this up. So we have possible solutions of x equals -2, comma 12. You would put in the Desmos like, or Moodle like this, -2, comma 12, but you got to check them. So let's take this -2, plug in for that x there. If you have a -2, does that equal 0? No, it does not. Okay. And now let's take the -2 and plug it in for the x right here. 5 times -2 plus 12, does that equal to 0? That's -10 plus 12. Nope, that does not equal to 0. So the 2 checks off. Okay. Now let's try the 12. Let's try that 12 right there. And some of you are probably like, why are we doing this? It's obvious that it does work, but it's just in case. It might not. Let's just be careful. If you put a 12 in for the x, you have 12. That is not equal to 0, so that checks off. If you put in 12 in for this, we have 5 times 12 plus 12. That's 60 plus 12, and that's 72. That doesn't equal to 0 as well, so that checks us off too. So we have two solutions, -2 and 12. And that's without using all that algebraic manipulation. Okay? We got one more problem that has an equal sign. Remember, what you're looking for graphing it, you can only do it when there's an equal sign. Okay? Got to do it when there's an equal sign. If there's not an equal sign like in this one, now it's out the door. It's out the window. Can't do it. Okay? Okay. Next oh, where'd it go? Oh, don't look at it. Don't look at that. I didn't know that was still there. Okay, so here we got the same one. We're going to again take this thing, this side. We're going to subtract it from this side. And so what we're going to have on the left side is x minus 15 over x plus 5 minus x minus 12 over x equals 0. And we're going to put that into Desmos. So we launched up our Desmos calculator. We'll close this one down, start typing into this one. Here's the key thing, because you have x minus 15 on top, you actually have to put parentheses to make sure it stays all together, x minus 15. And then once you type the x minus 15 in parentheses, leave it by pushing the right arrow and push the division sign, and you'll get in the bottom. And just, play around with this a little bit so you don't come to the test tomorrow like clueless on how to use this. I think it will make your life a little bit easier. So we have x minus 15 over x plus 5, and then we're subtracting. Again, we're going to put parentheses, x minus 2. And again, I don't care about my I don't know why you're asking me this right now while I'm making a video. It's kind of rude. All over x. Sorry about that. Okay, so we want to figure out, did I do this right? X minus, oh, it's x minus 12. That's the key thing, guys. Just make sure you type it in right. If you don't type it in right, you're not going to get the right answers. So we zoom on out. Let's see. What does it look like it's crossing the x-axis? Looks like right about here. So since it's crossing the x-axis right about there, ooh, I gotta pause this 1 second. I got people at the door. Pause it. Okay, sorry about that. Some students came in. So we're looking at this graph. We're trying to figure out where it crosses over the x-axis. We see they have a nice little dot there at 7 point. There's another one here. That's kind of weird. I don't know why they have that dot there. That's really weird. I should look someplace else. No, but it's not at a height of 0. See, because it's at a negative 0.2. So I'm not sure the purpose of that dot. Maybe that's where there's a hole or something. Why we have to investigate that. That could be where there's a hole. But we got a solution of 7.5. When it's at x is 7.5, it's equal to a height of 0, which is great. That's what we're looking for. So we want to make sure 7.5 is a solution, a true solution. So we got x equals 7.5. We're going to check that in here. 7.5 plus 5 equal to 0. Nope. No, it's definitely not. It's not equal to 0. That's supposed to be an n right there. So, and then if you put a 7.5 in for this, that does not equal 0 as well. So this is the solution, and you're going to put that in Moodle like this, 7.5. That's all you're going to do for that one. Okay, so that's how you can use Moodle to solve some of these problems. Now let's go back. Let's go back and then solve this problem right here. Got one of these to do. So we got 5 over x squared plus 7x plus 10. And we got to solve this problem right here. First, we're going to factor the bottom. We get a 10 and 7, and that would be a 5 and a 2. So we have 5 over x plus 5, x plus 2. Okay, and then we're subtracting a 4. We're going to factor this bottom. Negative 6, negative 1. That's 3, 2, negative. So 4 over x minus 3, x plus 2 right there. Okay, so that's how you do that right there. We're trying to get a common denominator. We look at this denominator here. It's got an x plus 5, x plus 2. This one has an x plus 2, but it doesn't have the x plus 5. So let's bring an x plus 5 over here, top and bottom. And this one over here doesn't have the x minus 3. So we'll bring that on top and bottom by multiplying it. Now that we have this over here, we got one nice good denominator of x minus 3, x plus 5, x plus 2. And then we're going to focus on the top right here. Here I have 5 times x versus 5x, 5 times negative 3, which is negative 15. We're subtracting this whole thing, because of the subtraction sign right there. 4 times x is 4x, 4 times 5 is plus 20. Now we're going to combine some like terms. So we got the 5x minus 4x, which is just x. And then we have the negative 15 minus 20. Negative 15 minus 20, this is where they make mistakes, would be a negative 35. That's all over x minus 3, x plus 5, x plus 2. And that's how you solve this problem right here. That's your final solution. Nothing to factor, nothing to cancel out on that problem right there. I'm going to pause it one more time. Okay, so I had some requests on solving these problems without using graphing calculator, and I'm going to do it, but I'm just going to say that when you do algebraic manipulation with these, there's a lot that goes into it, so a lot can happen when you're doing that. So with that being said, let's do it. Hopefully we won't make any issues. Remember, the first thing we're doing when we're solving things, we need to get a common denominator just like before. The common denominator for this, we got a factor, so we got an 8 and a -6, so that's -4 and -2. Thankfully, it was given to us right there. It kind of tells you, right? Who would have guessed? -4 x minus 2. This x minus 4 right here is missing the x minus 2. And this x minus 2 is missing the x minus 4. Stop knocking! Pausing again. Okay, I'm sorry I yelled. Sometimes I get so frustrated. Okay, so now we got the common denominator. When we get a common denominator, we just focus on the top. We only care about the top for now. So, let's focus on that top right here. If we focus on this right there, we have x squared minus 4x plus, that's for the plus, x minus 2 equals 2. We're going to combine, see the square? So we have the square right here. That means we're going to try to get everything to one side. So I have my x squared, my minus 4x, and my x is minus 3x. When I bring this 2 over, I got a minus 4 on both sides. So, and this is all equal to 0. I know I did a lot there. Let's just kind of pause for a second so you can see what I did there. I brought this, oh, that should be a 2 right there. Brought this 2 over. -2 minus 2 gives me a -4 on this side. And this -4 and that x gives me the -3x. Now we're going to factor this right here. So I got -4, -3. What times what is -4? That got to be -3. Pretty sure that's 4 and 1, and this becomes the negative. So I got x minus 4, x plus 1 as my possible solutions. That's equal to 0. So my two solutions could be 4 or 1. Let's take a look. Oh, check this out. 4 can't be a solution because that makes this 0. So the only possible solution would be 1 on this one. That's the only possible solution is x equals -1. I'm sorry. -1 because we need to make that a negative. Okay, only possible solution is -1. Okay, so that's how you solve that one. Let's find the other one with the equal sign. Oh, here. Gadahoon, this one's for you. Okay, we're going to do cross multiplication. Bring that sucker up there. Bring that sucker up here. So I get 2 times 5x plus 12 equals x squared. This is really, if we bring that 2 in there and there, we get 10x plus 24 is equal to x squared. Okay, I'm going to subtract 10x on both sides. And subtract 24, subtract 10x, subtract 24. And I get 0 is equal to x squared minus 10x minus 24. So what times what is -24? That adds together to be -10. 6 and 4, both are negative ones. -6, -4. So take the -6 and did I do that right? Hopefully I did that right. -6, -4. It seems I missed something here. Hope not. Okay, so I got my -6, x minus 6, x minus 4 equals 0. So my solution is x equals 6 or 4. Those are my possible solutions. Where did I go wrong on this? Because that's not what we were getting before, was it? And both of them make the denominator equal to 0, or neither makes them 0. So did I do something wrong? 2 times x, 2 times 24. Subtract that, subtract that. Got x squared 5x. What did we get on the graph of this? Let's go back to that graph. So we graph that. That one was this one, right? Oh, we got -2 and 12. -2 and 12, -2 and 12. -2, right? Right there. And 12 right there. What? Well, this is frustrating. 2 times 5x plus 12 and x squared. 2 times 5x, 10x. I'm going crazy. 2 times 12 is 24. X times x, we get the x squared. We subtract 10x, we subtract 24, we get -10. Did I do this wrong? -6 and 4 is -24, -6 and 10. Oh, gosh. Okay. I found it. I found it. Crazy me. Crazy me. That's why I got to double check right here. Okay. So this should be 12 and 2, and then the 12 is negative, 2 is positive. So then this would be x plus 2. Let's erase this. This should be x plus 2, x minus 12 equals 0 right there. And then the two solutions right here would be when x is equal to negative 2 or 12. If you take either of those, negative 2 or 12, so they don't make either of those denominators equal 0, so they both check off as being correct. Okay, check those mistakes. Okay, and we got one last one right here. Again, got to this for you. Cross multiplication right up there, right up there. So I got my x times x minus 15 equals x minus 12 times x plus 5 right there. Okay, so this is really x squared minus 15x equals this times this is x squared, this times that is 5x, this times this is negative 12x, and that times that is negative 60. Yeah. Okay. I notice these x squareds will cancel off if I just kind of look at that. And so we got, I'll add 15x to, now let's keep that on that side. Let's rewrite this. Negative 15x is equal to, combine these, and negative 7x minus 60. I'll add 7x to both sides. So I got negative 8x equals 60 negative. Divide by negative 8. Divide by negative 8. And we get x is equal to 7.5. There we go. That's my 7.5. 7.5. And we check that. That doesn't make this equal to 0. And that doesn't make this equal to 0. So that is your solution. Okay. So there I go. I went through every problem on there. Hopefully this helps some of you out.